Hello, my name is Jody Perkins, and welcome to my PowerPoint on how are elements organized on the periodic table. We'll be looking at Mississippi Standard CHE.2. Students will demonstrate an understanding of the atomic structure and the historical developments leading to modern atomic theory. Scientists in the early 1860s were looking for a way to organize the elements, and Dmitry Mendeleev discovered a pattern in elements in 1869. He found that when the elements were arranged by similar properties, the pattern, which was periodic, was observable. So that's why he named it the periodic table of elements. It represents our understanding of the structures and usefulness of the atoms that have been identified in our environment, and elements are organized on the periodic table based on similar properties. Here's an example of a periodic table without any colors so that you can see what it looks like. And one of the things that you notice is that every element is in a block, which we call an element key. Selected here is the element helium, element number 2. Helium is the second element. The element name is sometimes printed at the top, sometimes it's not printed at the top, sometimes it's actually the second thing down. The atomic number for helium is 2, which that tells you how many protons that atom has. The symbol for the element is He, so this is a way you can abbreviate the name of the element. And the atomic mass is rounded to 4.0026. That's the average number of protons and neutrons and electrons that it has. Atomic mass is the mass of one atom of the element. So what do you notice about this periodic table of elements? You notice that going across, they go up incrementally by 1, and going down, they go up by more than 1. So atomic mass increases as it's going left to right, and it's going from top to bottom. So how is it arranged? It's organized like a big grid. The properties of an element can be predicted based on its position in the periodic table. There are rows that go from left to right and columns that go up from down. Each row and column means something different. The periodic table can be divided into 3 main types of elements: metals, metalloids, and non-metals. So the metals are in light yellow, the metalloids are in purple, and the non-metals are in green. So you can see that most of the elements are metals. Metals are shiny, they're solid at room temperature for the most part, they have a high conductivity, and they can be flattened and they don't shatter, they're malleable, they bend. Non-metals are not shiny, they're usually dull, they're mostly gaseous at room temperature, they're poor conductors, and the solid non-metals are brittle and will shatter easily. Metalloids have characteristics between metals and non-metals. Some are solid at room temperature, and they are semiconductors. They will conduct electricity under certain situations. Each horizontal row on the periodic table is called a period. Each row represents the number of elements levels present in an atom of the element. The columns are called groups. There are 18 groups. The elements in a group have the same number of electrons in their outer energy level, which is called the valence levels. They're often grouped together to form families because they have similar properties. You know how a family has several members who look alike. The elements in a group of family of periodics often, but not always, have similar properties. Although you are not expected to know the names of the elements and the family groups, here's a quick glance. So you can see groups go from left to right. There's 18 groups. The periods go from top to bottom, and there are 7 periods. Atoms will often take, give, or share electrons in order to have a complete set of electrons in their outer energy level. Elements whose atoms undergo such processes are called reactive and can combine to form compounds. Since groups are similar because they have similar numbers of electrons in their outer energy level, the periodic table is organized by degree of reactivity. In general, elements located on the left of the periodic table are the most reactive elements, least reactive elements in the middle, and nonmetals are on the right.